So sometimes I'm really kind of fascinated by like books. So there was an article that ran in Chemical Engineering News a long time ago saying that we teach a lot of reactions in organic chemistry that are very esoteric and no one would do, but like we just teach them because historically they've been taught. And I really think the one we're talking about today is kind of like one of those reactions. So let's say I take an alkane, in this case one cyclohexene, and I want to make a diol. How would I do it? Well, the most practical way, and I say practical because potassium permanganate's dirt cheap, that's why you do labs with it, is to use KMnO4. Now, this is not to say KMnO4 was without limitations here. If you add KMnO4 in high concentrations and high temperature, you won't form the diol, you will end up forming the double aldehyde. But if you do low concentrations and you do low temperature, what you'll end up generating is the cis diol. So in this case, we get 1, 2, cis, 1, 2, cyclo, hexa, diol. Now, another way we could do this, and again, I'm only teaching it to you because your book says it. I have no earthly idea why you would ever practically run this reaction, is to use osmium tetraoxide or osmium VIII oxide in the presence of tert-butanol and a strong base, probably sodium hydroxide. Now, this will have the same outcome. You will end up forming the cis 1,2 cyclohexadiol. I'm guessing that this is a more selective reaction, meaning that you're unlikely to form the aldehydes. Now, why do I say this is an esoteric reaction? You probably shouldn't be doing it. Osmium and iridium are more valuable than gold. So you using OSO4 to run this type of reaction, whereas you can run this reaction potassium permanganate for like dirt cheap. Again, colleges do this reaction for that very reason. I don't know, and personally I can't find any literature to explain why you would do one reaction over the other, but here we are. This is one of the things your textbook talks about, so I'm going to address it. To get the same outcome as potassium permanganate, you can also use osmium tetroxide in the presence of tert-butyl alcohol and OH groups. This will give you the cis addition. They're added to the same side, and just another option in terms of your synthetic toolbox.